everyone, welcome back to our channel. In today's video, we're going to break down the push method in our priority queue class. This method is crucial for adding elements to our priority queue while maintaining the min heap property. Let's start by writing the push method. First, we check if the heap is full. If heap size is equal to the length of the heap array, we throw an exception. This ensures we don't add more elements than the heap can handle. Next, we place the new value at the end of the heap. We do this by setting the element at the current heap size index to the new value. Now we need to ensure the heap property is maintained. We use a while loop to bubble up the new element to its current positions. Within the loop, we calculate the parent index of the current position using the formula position subtract by 1 divided by 2. If the parent's value is less than or equal to the current value, we break out of the loop because the heap property is satisfied. If the parent's value is greater, we swap the parent and the current value using a helper method called swap indices. We then update the position to be the parent's index and continue the loop. Finally, after the new element has been correctly placed, we increment the heap size by 1 to reflect the addition of the new element. Let's write the swap indices method. First, we create a temporary variable temp to hold the value at index I. This ensures we don't lose this value during the swap. Next, we assign the value at index j to index I. This moves the value at j to the position of I. Finally, we place the value stored in temp into index j. This completes the swap, with the value at I and j being exchanged. The swap indices method swaps the value of two elements in the heap array. This is useful when we need to adjust the position of elements to maintain the heap property. To summarize, the push method adds a new element to the heap and then bubbles it up to maintain the min heap property. This ensures that the smallest element is always at the root of the heap.